Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of sections with cutout holes. Let's go to the numerical. A solid consists of a right circular cylinder and a hemisphere with a cone cut out from the cylinder as shown in figure. Find the center of gravity of the body. Here you can see here hemisphere is there and then a cylinder is joined face to face. Okay, like this. And from this section, a cone that has to be removed. So the portion of the hemisphere and then the cylinder that have to be added, then the portion of the cone that has to be subtracted. Okay. And then here, it is symmetry about the x-axis passes through the center of gravity of the section. Okay. So here we don't want to calculate y bar. Okay. I just draw the reference axis for y bar and x bar calculation. We know that we will take the bottommost line or otherwise the line or axis which passes through the bottommost point or line. That will be the reference axis for y bar calculation. Same way, the axis or the line which passes through the leftmost point or the leftmost line, that will be the reference axis for x bar calculation. Here you can see this whole section is symmetry about the horizontal axis. So you know the center of gravity will lie on this horizontal axis, but it may be anywhere along the axis. But whatever it is, when the center of gravity of the whole section lies with this axis, the distance of CG from the reference axis, that is the bottommost line, this one, that will be same. So here you can see the y bar value that will be equal to this vertical distance of the cylinder 120, that divided by 2, that means it will be 60 mm. From here to here it will be 60 mm. Do you understand? So we don't want to calculate y bar here. So we are going to calculate only x bar since this is symmetry about the horizontal axis. Okay. And then x bar. Here, a hemisphere is there and then a cylinder. From that, a cone has to be removed. So there are 3 segments are there. So I'm going to consider semicircle as the segment 1, cylinder the segment 2, then the cone that will be the segment 3. And then here you can see 1 and 2 that has to be added, and from that 3 that segment has to be subtracted. Okay, so I can write the formula here. Then hemisphere, cylinder, cone, these are all the solid bodies, and here the densities are same since no conditions are given. So we are going to consider volume. Okay, so v1 x1 plus v2 x2 minus v3 x3 divided by v1 plus v2 minus V3. Okay. This formula, for the reference, this is derived in a separate video, that is center of gravity by moment method. And then the formulas, that means volume, x, y values of hemisphere, cylinder, cone, that and all discussed in a separate video. An overview of center of gravity. Okay. So the reference videos, an overview of center of gravity by moment method, both the video links have been attached with the description box of this video. Okay. So go to the description box, watch the, that means by clicking the video link, watch the video. Do you understand? So from that will be helpful for better understanding of this video. Okay. So here, X bar. First, I'm going to start with V1, V2, V3, X1, X2, X3. Okay. And here, this is a schematic diagram. I just to draw the diagram here in 3D. Like there is a hemisphere, and you know that this will be the hemisphere, and the cylinder, that is face to face join like this. Okay, hemisphere and a cylinder joined, and this is the common face. From this, a cone has to be removed. Okay, this is the cone that going to be removed from this. Okay, I'm going to hatch the cone. That portion only going to be removed. Do you understand? Hemisphere, cylinder, then the cone has to be removed. I just start with the hemisphere first. Okay, first of all, hemisphere. We know that the hemisphere, the segment 1, here V1. The volume of the sphere, that will be 4 pi 3 pi r cube. Volume of the hemisphere, that will be half of that value. So we can write V1, that is 2 by 3 pi r cube. That equal to, here you can see the radius of the hemisphere from this one to this one, 120. That will be the diameter. So the radius, that will be 60 mm. So substitute the value 2 by 3 multiplied with pi multiplied with 60 cube. Then by simplification, we will get the value of V1, that is 1,44,000 in terms of pi mm cube. You can substitute the value of pi 3.14. Further simplification also we can do. Okay. Then X1. We know that X1 from this point, because this is the reference, this distance, okay, this distance, that will be 5 r by 8. Okay, that is actually 5 r by 8. So X1 is 5 r divided by 8. That equal to 5 multiplied with the radius, that is 60 divided by 8. So when you simplify, we will get X1, that is 37.5 mm. Then we got to do the calculation for the second segment, that is cylinder. Okay. So cylinder, the segment 2. Okay. In cylinder, the volume of the cylinder V2, that equal to pi r square h. Radius of the cylinder. Here you can see this is the common radius for hemisphere, cylinder, cone, everything same. Okay. And then the height of the cylinder, this will be the height. This will be the height for the cylinder. That will be 150 mm. So pi radius 60 square multiplied with the vertical height. That means here it is horizontal 150. So by simplifying, we will get the value of V2, that is 5,40,000 in terms of pi. 5,40,000 pi mm cube. We can substitute the value of pi, that is 22 by 7 or 3.14. Further simplification also we can do. Okay. Then x2, that is, cylinder is as usual like the rectangle. Its center of gravity will be the dimensions divided by 2 from linear or vertical. So the CG2 of this cylinder, that will be here, that is 150 by 2. That is from this point, 150 by 2. But we need from the reference. So the reference axis to this point, that is radius 60 mm, 60 plus this distance, 150 by 2. Okay, so that will be 60 plus 150 divided by 2. Okay, 150 by 2, that will be 75 plus 60. We will get 135 mm. Okay, so this is x2. Okay, so x2 also we calculate. Then we got to do the calculation for the removed portion. That is cone, right circular cone, that is the segment 3. So V3, the volume of the cone, that is 1 by 3 pi r square h. Radius and then the height of the cylinder and the cone, both are same. So now substitute the values. 1 by 3 pi radius 60 square, vertical height here, but it is horizontal 150. So we know that we will get 1/3 of the volume of the cylinder here. By simplification, we will get V3, that is 1,80,000 pi. 1,80,000 in terms of pi mm cube. And guys, here you can substitute the value of pi, 22 by 7 or 3.14. Then we can multiply this also. Further simplification. X3, but it will be large. That's why I keep in terms of pi. Then x3. We know that the CG3, center of gravity of the cone, that will be from this point. That means from here, 1 by 4h. From here, that will be 3 by 4h. Okay, that will be 3 by 4h. But the 3 by 4h is from this point. From here, we have to calculate. That is x3. Okay, reference axis for x bar calculation. So from here, this distance, that distance is radius, 60 mm. So that 60 plus 3 by 4h. Okay, that is 60 plus 3 by 4h. 60 plus 3 by 4. The h value is 150. So by simplifying, we will get the value of x bar, 172.5 mm. 172.5 mm. So now all the values we have, substitute in the formula x bar, that is V1 x1 plus V2 x2 minus V3 x3 divided by V1 plus V2 minus V3. Substitute all the values in the formula. X bar equal V1 1,44,000 pi Okay, 1,44,005 multiplied with x1, 37.5. Then plus V2, that is 5,40,000 pi. 5,40,000 pi multiplied with x2, that is 135, minus the third segment V3x3, that has to be subtracted. Here no space, that's why I just write below. But this is a straight values. Okay, V1x1 plus V2x2 minus V3x3. Okay, so V3 1,80,000 pi multiplied with x3 172.5, the whole divided by V1, that is 1,44,000 pi plus V2, that is 5,40,000 pi minus V3, that is 1,80,000 pi. Okay, then further simplification, we will get the value of x bar, that is 93.75 mm. Okay, so this is x bar of the given section. Okay, so here you can see hemisphere, so a cylinder that have to be added, the portion of the right circular cone that have to be removed. Okay, I hope you all understand the numerical what we discussed in this video. Don't forget to subscribe my YouTube channel Vishwas Guru, a problem solver, for more number of videos like this. Okay, thank you guys, thanks for watching.